Hi, CP Math 1, glad you're here. We're going to go through the Chapter 6 study guide, starting with question number 1. The first set of questions are true, false, and you're asked to write the word true or false in this column for each of the following expression or types of expressions. So the first question is, parallel lines have the same slope. And that's absolutely true because if we think about just a moment, right, if we've got a rise and a run, and then over somewhere else we have the same rise, the same run, these lines that we're going to create here are going to be parallel to each other. They're not going to intersect. So whenever two lines have the exact same slope, they will be parallel to each other. So I'll write the word true here, although you should write it in the column over there. One thing is also true is that if lines have slopes that are opposite in sign and reciprocals, then they are perpendicular to each other. So if I have a slope, for example, of like 2/3 and a slope of -3/2, if I was to look at those two lines, up to over 3 compared to down 3 over 2, if I was to sketch those lines, where those lines meet, we would be forming a right angle. So if lines are opposite in signs, here this one's positive, this one's negative, and they're reciprocals, meaning the numerators and denominators are swapped. Whenever we see that, we have perpendicular lines. Next question says x to the 0 times x to the first times x to the fifth times x to the fourth is the same as x to the 20th power. Well, when I look at this, x to the 0 power is just equal to the number 1. So I'm multiplying by 1. So that doesn't change anything at all, right? That's just the number 1. But then I do have 1 factor of x multiplied by 5 more multiplied by 4 more. There are a total of 10 factors of x being multiplied. So this is x to the 10th power. So I would have to say this is false, right? X to the 20th is not the same as this expression because this expression is the same as x to the 10th power. Next, the slope of the line y equals 1/2 x is positive. And that's true, right? We can see the slope parameters here. This is in slope-intercept form, so because of that, we know that this has a rise of 1 and a run of 2 units. So we roughly see what that slope would look like on a Cartesian coordinate plane. Next, the points 2, 1, and 6, 1 form a vertical line. So if I was to just quick sketch here, 2, 1 would be over 2, up 1, and then over 6, and then up 1. Well, when I look at that, this line formed is not a vertical line. This is a horizontal line, right? These two lines together are horizontal. So they're not vertical. A vertical line would be one where I think we would have the same x values and 2 different y values. So if I was to look at, for example, 2, 3 and 2, -5, right? 2, 3 would be roughly over 2, up 3, and then over 2, down 5 would be here. So if we have a situation where the x values are the same, then we would have a vertical line. So is this a vertical line? False. False. These are not forming a vertical line. Those are horizontal line. Next, the lines y equals 3/2 x and y equals 2/3 x meet to form a right angle. Oh, well, here we go. The question is, essentially, are these slopes, is this slope and this slope, are they opposite in signs and reciprocals? Well, it is true that they are reciprocals, right? I can see that one had a numerator of 3, the other one has a denominator of 3. This denominator was 2, and over here the numerator was 2. So I can see that definitely they are reciprocals of each other. The reason why they are not meeting a right angle, the reason why they're not perpendicular is because they do not have opposite signs, right? See, these are both negative. So because they're both negative, they're not forming a right angle. In order to get perpendicular lines, 2 things have to be true. Their slopes have to be opposite in sign and reciprocals. Next, the line y equals 5x plus 3 is horizontal, has a slope of 0. Well, that's... Oh, I forgot to answer this question. This one was false. This is false because those two lines They are reciprocals, but not opposite. Okay, so now on to F. The lines y equals 5x plus 3 is horizontal, has a slope of 0. This is false also. When I look at this, this has a slope of 5, which means it's going to go up 5 units and then to the right 1 unit, right? 5 is the same as 5 over 1. Definitely not a slope of 0. And then finally, the product of x plus 3 times x minus 3 is x squared minus 9. Now, the thing that's a bit tricky about this is a lot of times we would almost look at this problem and we could almost overgeneralize and come up with a shortcut that's not really a shortcut. So I am going to show this as a generic area model, and I'll use this space right here as a generic area model so that we can think about more broadly what's happening. So if I have these 2 by 2 boxes, right, I can write up here an x and then a plus 3, and right here I can do an x and a minus 3. When I multiply x times x, I do get x squared. Over here is a negative 3x, and then below that I have x times a 3, so this is a positive 3x, and then finally negative 3 times positive 3 is negative 9. So when I simplify this, because the 3x and the negative 3x will cancel, when I add those areas together they equal 0. It turns out that, yeah, this does have an area of x squared and then minus 9. So the reason why I caution you to be careful, though, is because if I was to say, hey, is x plus 3 times x plus 3 equal to x squared plus 9, the answer to that, surprisingly maybe, would be false. For up here, the answer is true. But we should moreover look at why this would be false and then not overgeneralize. So if I were to multiply these two, and let's go ahead and I'll make this a positive. This will change and this will change. So that one change alone, right? They're both x plus 3. Now this upper box becomes x times 3, which is 3x, and 3 times 3, which is 9. So now the difference is when I multiply, or when I combine the 3x plus 3x, I get 6x. So this is not the case, right? These are not equal. No, no, no. They're not equal. If I was to write down what that is, x plus 3 times x plus 3 equals exactly x squared plus 6x's plus 9. The 6x comes from the fact that I've got a 3x and a 3x, and when I combine those two, I get exactly 6x. So that's it for the first question.